The Army Ballistic Missile Agency was a crack team headed by old pros of the missile field. Dr. Werner von Braun, director of the Development Operations Division, supervised over 3,000 scientists, engineers, and technicians with more years of practical experience than any similar group elsewhere.
The first stage is an elongated redstone missile, with extra long tanks and a special fuel combination, which burns for approximately 145 seconds. Immediately after cutoff, we separate the front portion of this missile, the so-called instrument compartment, from the tank section. This instrument compartment is equipped with a special attitude control system, as we call it, that aligns this portion, including this spinning launcher in the nose, into an exactly horizontal position.
As early as September 1956, the Army, in cooperation with JPL, had successfully flight tested the first Jupiter-C.
2, 1, fire command,
The point of impact was more than 3,000 miles from the launching site at a predetermined spot off the coast of Africa. The purpose of the first test was to check the propulsion systems of the various stages, the problems of separation and ignition, and to demonstrate a new radio receiving technique called Microlock. In subsequent tests, the Jupiter-C successfully accomplished the task for which it had been developed: to test the effects of aerodynamic heating on a nose cone designed for the Army's Jupiter Intermediate Range ballistic missile.
The date is August 8, 1957. The time, 01:58 hours. Poised on the launching pad at Cape Canaveral, Florida, and with its nose cone spinning, Jupiter-C is prepared for firing. This successfully launched Jupiter-C followed its prescribed trajectory all the way to its target. Far out at sea, a Navy vessel stands by. A Navy frogman team from the recovery vessel has secured a line to the Jupiter-C's nose cone. Aided by a deck crew from the recovery vessel, a heavy line hauls up the submerged nose cone that conquered the critical re-entry problem of returning to the Earth's atmosphere.
Although the nose cone of the Jupiter-C missile plunged through the Earth's atmosphere with the speed and heat intensity of a meteorite, it suffered little or no damage. With the nose cone securely on deck, members of the scientific recovery team went to work. First, the parachute lines were separated from the nose cone. Compressed air was used to dry off any water which might have entered the nose cone and settled on the electronic equipment. All moving parts were cleaned and lubricated as a precaution against the corrosive action of salt water. With final cleaning and drying completed, the nose cone was transported to the test laboratory where gauges checked any changes in its configuration. Examination of the nose with a template determined the amount of wear due to intense friction and heat during flight and upon re-entry to the Earth's atmosphere.
This object here in my office is the nose cone of an experimental missile fired over a long distance. It has been hundreds of miles into the outer space and back. Here it is, completely unharmed, intact.
Once this nose section with the spinning cluster configuration in the nose goes through the apex of the trajectory, the top stages are fired. And there are 3 solid rocket stages in the top. So it's a 4-stage vehicle.
Jupiter-C stands poised on its launching pad. The hours-long countdown approaches 0. A moment of enormous tension, for every missile launching is still an experiment. Any one of tens of thousands of things can go wrong, with catastrophic results. But all that can be done to assure perfection has been done. The moment is at hand. The countdown reaches 0.
0. Pressurization starts. X plus 8, 9, 10, 11, 12, 13.
Some 3 minutes later, Explorer is in orbit.
The Army's first success had not washed away the rocket men's humility, for there are a countless number of things that can go wrong in the operation.
Here is the Explorer satellite, carefully covered, being hoisted to the top of the Jupiter-C rocket for installation. The Explorer was encased in a rocket shell, which also included fuel for the final burst of speed. At its base, it was attached to other rockets, which would carry it to the necessary height. This rocket uses liquid fuel in its large first stage and solid fuel for the other stages. To enable the fuel to burn at high altitudes, the first stage uses liquid oxygen, which is extremely cold.
Personnel should evacuate the area at this time.
Explorer 2, fired successfully, had failed to go into orbit because of one tiny component in the last stage. Just under 2 months after Explorer 1 was put into orbit, and close on the heels of a successful firing of the Navy's Vanguard, a launching pad at Canaveral awaited another Army satellite, Explorer 3. Along the Florida beaches, many fingers were crossed as eyes stared toward Explorer 3. Shortly before launch, the upper stages are set rotating. If the spin were not provided, the payload would be hopelessly deflected. The scientific and technical prestige of the United States was enhanced. Now, Americans could once again look up toward their future with faith and with confidence.
The next United States success in space came with the launching into orbit of Explorer 4 on July 26, 1958. As a scientific experiment, it confirmed and expanded the data on radiation and temperatures discovered by satellites Explorer 1 and 3.